Hello, today we are going to share a question on properties of a circle. So another topic that I feel when students move up to the Sec 4 level, they claim that this is one of the hardest topic. Because there's quite a couple of things to memorize, is for sure, okay, number one. And second is that sometimes when you see the question inside a circle with so many lines being drawn over there, it could be a little bit hard to spot for the right ones to solve the question, right? And it could be a little bit also challenging to like try and locate which is the kind of theorem to use to solve for a particular part. And sometimes if you don't switch around your point of view, if you didn't change your point of view to focus on different parts of the circle, you probably won't be able to find that angle. Okay. So let's begin with question one today. Okay, if you're still keen on another one more sharing session on properties of circle, please look forward to the next one. All right, take some time to read the question, and they only did mention that AB is a diameter, right? And then they said that DB bisects angle ADC. So you've got to remember what bisects means. Okay, so bisects means that you will basically cut the angle equally into two parts. All right. So immediately, actually, you can just find out the angle from the left and on the right. They are supposed to be the same, which means that your 56 is representing 2 units. Yeah. All right, so they only give us one angle, which is ADC itself, and they want us in part one, part one want us to find DCA. All right, and because they tell us that AD is a diameter, so if you focus on this triangle here using the diameter and DCA, basically you will know that there is one property that you can immediately use, right? What is that angle called? Okay, it's 90 degrees, yes, but then what is the angle property? You also got to remember. It is called right angle in a semicircle. Okay, so let me just say it again, as long as you have a diameter and you have a third point that is on the circumference of the circle, right? And it forms basically a triangle that comes from the diameter. So that angle on the circumference of the circle is always 90 degrees. And that is a property that you have to memorize, right? One of the properties of circle. All right, second one. Find angle CBA. All right, CBA is here. And what kind of point of view should we be focusing on? Do you have any ideas? Do take some time. Sometimes you might have to pause the video for a little bit, right? To give yourself a challenge to see if you can solve before I do, right? All right, so the answer is that you have to look for this four-sided figure in the question here, in the circle, in which that you will remember there's one property that involves opposite angles, diagonally opposite angles. So it must be totally across, right? Of a four-sided figure inside the circle, in which all the 4 points touch the circumference of the circle. So you cannot use this property if you have something like that. Okay, if one of the point is not on the circumference, all the points must be on the circumference, that's the only way you can use this property. And the property is such that the diagonally opposite angles will add up to 180 degrees. And what is that name of this property called? Do you remember that? All right, the property is called angles in the opposite segment. And we got it. Okay, the third one is to find AEB. This one here. Now, if you just simply focus on the triangle on the left side here, you probably won't be able to solve because in fact, there is not a single value at all, right? And also, this question didn't say that EB is a diameter, so do not assume that this is another 90 degree there. Let me say again, the question haven't reviewed any information about EB being the diameter, so do not use right angle in a semicircle for here. We do not know whether it's 90 degree yet, okay? So the only thing we can do that we haven't really done just now is that I mentioned that DB bisects the angle, right? So that means that if I, let's say, find angle XDB, that will be using the 56 divided by 2. Because bisector means that it's able to cut into 2 equal parts, right? All right, and there we go. This is the important angle that can help us link to angle AEB. Do you observe another circle properties here? And that is, if you use the common point AB, right, and you create a third point here, create like an angle on the circumference here, right, ADB. And if you, let's say this is an interactive point and you're able to drag this point D around, keeping the pivot as AB, that means A and B do not move. You just use the D to drag it around the circle. And when the point, when the time it reaches point E, you will be able to see that, hey, I will be able to get the same angle. So which means that angle AEB is also going to be 28 degrees. And what is the reason for that? It is called angles in the same segment. Okay. All right, there you go. We saw some of the angle properties. So there are quite a couple of more you've got to memorize, right? Including the tangent that is perpendicular to the radius, right? And also tangents, external points, tangents to external points, they will be identical, which means that if you have a tangent here and a tangent here, oops, not trying to scale. All right, and if you create a triangle outside this circle, it's going to be an isosceles triangle here. All right, and not just that, they are, if you cut into two, there will be identical triangles on the left and right as well. Yeah. This is called tangents to external point. Some small recap that perhaps can help you. All right, in part B, they say that EB is parallel to DC, so we mark the parallel lines. And they also say that EB cuts the AD at X. And then the question that says that you cannot assume that X is the center of the circle. Now, if you can't assume X is the center of the circle, this also means that you cannot assume EB is the diameter, right? Throughout the whole question until now, they didn't say anything like that. So the only extra information you can use is the parallel lines only, okay? But I'm also going to put in some numbers that we already found out earlier, which is that this is 28. This is also 28. My angle CBA, 124. All right. And if you do not have, if you cannot say that this is diameter, you cannot say this is the center, you cannot use the fact that right angles in the semicircle. Likewise, if this is cannot be assumed to be the center, you can't say this is radius as well. So there are quite a lot of things you can't use in this question, but then you must remember the question do not give us extra info for no reason. So the probable reason why they give us a pair of parallel lines is for us to use it, all right? And where is that pair of parallel lines? Probably here. Okay. Because the idea is to basically focus on this triangle DBX here, to say that it's isosceles. We already know this is 28 degree. If we can find out that this other angle on the bottom part here, angle B, is it also 28 degree? If it's also 28, then this will confirm this isosceles, isn't it? All right, so how to get that angle is basically to look at this alternate angle formed by the parallel lines. And if you know that if the bottom part is 28, your angle CDB, sorry, is also going to be 28 degree, right? Because of angle bisector. All right, and then this will help you to be able to link to angle B here at the bottom. This must also be 28 due to the fact that you can use alternate angles. All right, cool. Now, after that, with these alternate angles, we can then prove that triangle BDX is isosceles. And the reason property is by base angles. Basically, base angles of an isosceles triangle means that there are the two angles, they are the same, right? Those are called base angles. Okay. All right, still two more parts to find. So let me erase some of this earlier answers so that I have space to write, okay? All right, the next one for part C says that we want to find angle EBA. Do you have any idea how to get there? Now, once again, we haven't proved that the EB is the diameter. We haven't also proved that X is the center of the circle. Even though this is an isosceles triangle, which is you have equal lengths on the left and the right, there is still not enough information to prove it's the center, because you could also form any other triangle inside the circle that creates a isosceles triangle that doesn't touch the middle. Do you agree? It can be anything. It can be a much like shorter triangle, maybe like that, and it could also be isosceles, isn't it? It doesn't necessarily have to touch the center. So which brings us to question C. How do we begin? All right, even though we know that we don't know whether EB can be a diameter, right? But DA is confirmed a diameter, isn't it? So we do have another right angle in the semicircle here. You see that? DBA, right? This is the diameter and it's a right angle formed inside the semicircle here. So angle ABD, 90 degree. All right, and then we can find EBA by using 90 to subtract this 20 away, right? Sometimes if you are stuck, you've got to try and find the link that comes from the previous part of the question. Like earlier, if in part 3, you have solved something around that side, like the angle that we solved was 28 degree over there, right? So perhaps we're going to use it. And yes, it just so happened that if you're able to minus that 28 here, you will be able to find the angle at the bottom, which is the EBA that you want. Oh, sorry, this is EBA, but not EEB. So I think this is question 4, right? I think I said question wrong. This is. Oh, I'm sorry, I looked at the wrong question. I've already done part 3 and go back to part 3 again. Okay, so you go to EBA here. It should be this angle that we are finding. So 90 minus 28, that will be the answer. All right, and this one don't need any angle properties, just using 90 degree to subtract the top part, look at the bottom angle, right? All right, in part D, they say hence or otherwise prove that the X is the center of the circle. Now, if you focus on again, the previous answer in C, if you have the 62 here, and probably the focus point will be here as well, with this triangle EBA at the bottom, because if you focus on that triangle, I'm sorry, all right, sorry for the delay. Okay, so if you focus on this triangle at the bottom here, there is only one last angle to found. And once again, we do not know whether it's diameter or not, but we can work backwards to check to see what angle is angle A. Because if angle A proves to be 90 degrees, then we can use the property of right angle in semicircle to prove that EB is another diameter, right? So let's do that. We use angle sum of the triangle, basically 180 subtract the 28 and 62. You will know that angle EAB is also 90 degrees. So this is just angle sum of the triangle. There is no, you cannot put in right angle in semicircle yet, okay? Because at the start when we use 180, that is the reason that we introduced. It's based on the total sum of 180 degrees. Okay, so after you get that, this to be 90 degrees, then you can prove that EB is the diameter by saying by right angle in semicircle. EB is the diameter. And when you see any two diameters meet at one point, if they intersect at one point, that one point must be the center. So you say EB and EB intersects at X. Which must be the center of the circle. All right, thanks for the lesson today. I will see you next time.